Hello everybody and welcome back. I hope you all had a great fall break. So this is lesson 1 for regular algebra 2 and this is lesson 2 for honors algebra 2. So we are going to be doing Cramers rule, which is something new for algebra 2 CP periods 3, 6, and 7, but it's pretty simple. We are going to spend about a week on this, and we'll have some kind of assessment at the end on Friday. So honors, this is just a second thing in your tool belt to solve 3x3s. Okay, I hope you all have your calculators handy, and we're going to do an evaluation of what we call a determinant of a 3x3, so you know how to do this, and then we're going to actually solve a system using Cramers rule to solve a 3x3. Okay, so let's get started. So algebra 2 CP periods 3, 6, and 7, a third order determinant is a numerical answer that we can use to solve a system. So I'm going to show you what it is. In order to do this, we have to set up a 3x3, and then we're going to recopy the first two columns, and then we're going to do what we call the down diagonals minus the up diagonals. Okay, and if you look up here, this kind of states everything that we're going to do. So I think the easiest thing to do is to show you by an example. I have mine all done, so I have all my numbers all written, but if you want to check something, maybe have your calculators there. One thing you want to remember is when you rewrite this, make sure you leave enough space between the columns, and make sure you copy the problem correctly, because if you forget a negative, obviously your answer is going to get wrong, and if you squeeze them together, you're going to think it might be a 26 instead of 2 and a 6. Okay, so here we go. Okay, so the very first thing we need to do is we need to recopy the system, and you're going to recopy the first two rows. So you're going to go 4, negative 3, negative 4, and we're going to slide over a little bit, and we've got negative 8, 2, 5, and 3, 6, 9. Then we're going to recopy the first two columns. Columns, remember, are ones that go up and down. They hold up the house. So 4, negative 3, negative 4, which is the first column, and the second column is negative 8, 2, and 5. So I'm going to double check to make sure that I copied it right. And it looks like I did. Okay, so now what we're going to do is we're going to take what we call the down diagonals minus the up diagonals. Okay, I'm going to do the down diagonals in red. There are 3 down diagonals. You start in the upper left-hand corner, and you go down. That's 1, and we're going to multiply all those together. And when we do that, you get 4 times 2 times 9, which is 72. Then we're going to do the second down diagonal, which is negative 8 times 6 times negative 4, which is a positive 192. And then we're going to do the third diagonal. Down diagonal is 3 times negative 3 times 5, which is negative 45. So what we're going to do is we're going to add all those up, and when you do that, you get the down diagonals are 219. Okay, now we're going to subtract the up diagonals. So I'm going to start in the lower left-hand corner, and we're going to go up. And when I do that, I get a negative 4 times 2 times 3, which is negative 24. Then we're going to do the second up diagonal, which is 5 times 6 times 4, which is a positive 120. And I'm going to do the third diagonal, which is 9, negative 3, and negative 8, which is a positive 216. So when I add all those together, I get 312, and that's my up diagonals. Okay, so for the determinant, and I didn't really explain what the determinant is. The determinant is represented by these straight up and down bars, and again, it's a numeric answer that we're going to use to solve the system. So you're going to take your down diagonals, so we're going to take the downs minus the up. So that would be 219 minus 312, which gives me a negative 93, and that is the determinant of this particular 3 by 3. Okay, now what we're going to do is we're going to go on to what we call a system of 3 equations with 3 unknowns. So that means there are 3 equations, and the 3 unknowns are x, y, and z, and we're going to use the determinants to solve for x, y, and z. Okay, so let's go ahead and go to the next one. Okay, so up here, this shows you how to use Cramers. So this would be something that you can look at. If you want to do that, I would probably go back and just kind of listen to me do it again, and we're definitely going to be practicing a lot in class. Okay, so here we go. We're going to solve this particular system. Now, in order to do this, you have to find what we call the determinant of the coefficient matrix. Okay, the coefficient matrix is this right here, and they come from the coefficients, which are the numbers in front of variable x, y, and z. Now, if you look at this, this is the x column going down, the y column goes down in the second, and then the z column goes down on the third. Okay? This is going to be called the coefficient matrix. They actually call it C. I actually just usually use CM for my coefficient matrix, and whatever we get for that answer is going to go on the denominator. Okay, now, when we solve for x, y, and z, x, y, and z actually use the answers, and they replace the column that you are solving for. So for solving for x, they replace the x column, and I keep the x and the y the same. If I'm solving for y, they replace the y column, and I keep the x and z the same. And if I'm solving for z, they replace the z column, and I keep the x and the y the same. Then once I get an answer, I divide by the coefficient matrix. Since we are spending only a week on this in CP, we're going to do it by Cramers instead of elimination. It's much easier for me to find your errors. So here we go. Okay, so the very first thing you do then is you're going to find what we call the coefficient matrix first. Okay, so the coefficient matrix has to be a number. If it's 0, then that means we will have a special answer, either no solution or infinitely many. CP, we are not going to worry about that this week, so you don't have to worry about it, so I'm not going to even go over it in class. The Honors Algebra 2, we will definitely be working with that, and it goes along with our 2x2 that we did before October break. Okay, so here we go. We're going to copy our first column, so 4, 3, 7. Second column, 5, -2, -6. Last column, -6, 7, and -8. We're going to recopy the first 2 columns, and I'm going to again double check to make sure I copied it right. And it looks like I did. Okay, so the down diagonals I'm going to do red again. And these are the numbers I'm going to check. So when we go through and do these, if you're not getting the right answer, you have got to have these numbers down. So 4, -2, and -8 would be a 64. 5, 7, and 7 would be 245. And -6, 3, and -6 would actually be 108. So when I add those together, I get 417, and that would be my downs. Okay, if I change colors, let's go ahead and we'll do the ups. So the ups, 7, -2, and -6 is 84. -6, 7, and 4 is -168. And -8, 3, and 5 is -120. Okay, didn't leave me much room there. So when I add all of those up, I get actually -204, and those are my ups. So if you remember, we go the downs minus the ups, which equals 417 minus a -204. So that would be plus, and then I get 621. And that would be my coefficient matrix. Okay, so now we're going to do the x. Okay, well, if we solve for the x, if you remember, the 621 is going to go on the bottom. But at the top, we are going to take my answers, those, and we're going to replace the x with those answers. Okay, so negative 14, 47, and 15. We're going to keep the y column the same. And we're going to double check, make sure we copied them right. We're going to recopy the first two columns. And it looks like I did. Okay, so now we're going to go the downs. So we're going to go the downs. Oh, and notice I didn't copy the second row, so I need to recopy the second row so I have enough numbers. And the downs. Okay, so for my downs, I got negative 224 for the first one. I got positive 525 for the second one. And I got 1692, very big number, and that would give me 1993. Okay, so now I'm going to do the ups. Well, the ups would be this one, and this one. So the three numbers for the ups are 180 plus 588 minus 1880. Okay, and that one would equal negative 1112. So then the downs minus the ups would equal 1993 minus a negative 1112. Okay, so the x would equal 3105, but I got to divide by 621, and so I get 5 equals my x. Okay? A lot of work, but it's easier to find your mistakes doing it this particular method. Okay, we're going to slide her up and we're going to find my y. Okay. Okie doke. So let's do a different color for the y. We'll do blue. Okay, so the y then, we're going to have 621 down in the bottom. My y means we're going to replace the y column with the answer. So that says my x is going to be the same. So if we go back up to the top, we get 4, 3, and 7. My y's then become the answers, which are negative 14, 47, and 15. And my z's stay the same, which is negative 6, and 7, and negative 8. And I have to recopy the first two columns again. Okay, so let me double check. And it looks like I've got them. So now we're going to do our downs. Okay, so our downs will start here, here, and here. So my three downs would be negative 1504 minus 686 for the second one, and a negative 270 for the third, and that gives me a negative 2460. Okay, then we're going to go to our ups, and we got 1, 2, 3. So my ups are negative 1974 plus 420 plus 336, which equals negative 1218. So if we go back and we do our downs minus our ups, that would give me negative 2460 minus a negative 1218, which gives me negative 1242, so this would be my y's, over 621, which is negative 2, and that equals my y. Okay, so now here's what's something nice. Once you do Cramers with two of them, if we're going to take both of those answers, x is 5 and y is negative 2, and we are going to go back up to the original equations and we're just going to substitute it into one of the equations to get my z. Okay? You could also continue and do Cramers with your z as well. So if I go through, we know x is 5, and I know y is -2. I'm going to pick, the first equation is 4x plus 5y minus 6z equals -14. So let's plug it in. So 4 times 5 plus 5 times -2 minus 6z equals -14. So I get 20 minus 10, which is 9. Oh, that's not right. That's 10. Minus 6z equals -14. So if I subtract 10, I get -6z is -24. And I get z is 4. Okay, now to check it, I'm going to plug it into one other equation, and we're going to see if we have it correct. Okay, so if we know z is 4, we're going to check these three answers right here. So let's go to the second one. So 3x minus 2y plus 7z is 47. So let's check it out. 3 times 5 minus 2 times -2 plus 7 times 4, does that equal 47? 15 plus 4 plus 28, so that would be 19 plus 28 does equal 47, and 47 does equal 47. So my ordered triple is 5, -2, 4. And there you have it. So we'll be practicing this a lot in class. Hopefully you followed along. Again, if you wanted to use Cramer's rule for z, you can do that instead of substituting it in. Have a great day.